In this lesson, which is lesson 2.3, we're going to talk about how to solve a linear equation. Okay, this is based on Blitzer's intermediate algebra for college students. So solving a linear equation is really, really essential to any algebra. I want you to think of a linear equation. If it has an equal sign, as balancing both sides. If it tells you that both sides are equal, then if you do anything to the left, you have to do the same thing to the right. For example, if I told you something plus 2 is equal to 7 on this side, well, in order to find something, I could take 2 away from here, but I would also have to take 2 away from this side. If I took a 2 away here, take 2 away here, hey, x and 5 are equal, which you would know because 5 plus 2 is equal to 7. So think of it as a scale, and whatever you do to one side of the equals, you have to do to the other side. So oftentimes it's going to tell you to solve an equation. Basically, an equation is solved when the variable is on one side of the equal sign and the number is on the other. Now, you don't always have to have the variable on the left, but we typically like to have the answer so that the variable's on the left-hand side and the number is on the other. The solution can also be called the root, which we'll talk about later. A linear equation is just a mathematical sentence. So just like you have a sentence in English with a capital letter and a period, a linear equation has variables, constants, an equal sign, and so forth. And just like I said before, whatever you do to one side, you have to do to the other. You are allowed to add or subtract or multiply or divide or do whatever you need to do to isolate the variable to solve it, because the goal is I want to have the variable all by itself when I solve. I want the variable alone. Okay, so it says let's just use addition or subtraction to solve this equation. So I want x alone. The problem is x has 10 subtracted. So if I want to move this 10 to the other side, if I want x by himself, I'm only going to deal with the things that are not x, because x is already here. If I take a negative 10 and I add a 10 to it, guess what? It gets rid of the 10 on this side of the equation. So that now I have my x by itself. But by adding it to this side, I can't just add it to one side, otherwise it's not equal. Just like over here, if I were to add 10 to this side, the scale would not be balanced anymore. This left side would be heavier. But if I add 10 to this side and I add 10 to this side, well, now it's still equal. So that's what I did here, which means that x is 22. That's solving it. All right, now here, the trick here is not just adding and subtracting to get my y to be alone, because I got y's on the left, y's on the right. Oh my gosh, y's everywhere. But I need them all on one side and all the constants on the other, because if you'll notice, my answer always has the variable on one side and all the constants on the other. But the first thing I need to do is I can combine some like terms here, okay, on this side of the equation. 3 minus 8 is the same as negative 5. I don't have to do anything to the other side by combining those two terms because they're on the same side. I can combine in my 6 and my 9. I have 6 and 9 both on this side. I can just say, hey, that's the same as 15. I don't have to do anything to the other side. If I'm just combining terms on the same side of the equation, I just combine them. If I want to try to move things from one side of the equation to the other, well, now I have to do the same thing to both sides. So now I want to try to get all my variables over here. So I'm going to subtract 4y's from this side, which means I need to subtract 4y's from that side. My negative 5 is still here. My 15 is still here. Okay? 5y's minus 4y's give me 1y. What's wrong? I have my y all by itself except for this negative 5. But if I were to add 5 to this side, I would have y alone. But if I add 5 to this side, I have to add it to this side as well. And that is solving it. What happens if you have a fraction? We all love fractions, right? Well, I want x to be alone. Right now, x is being divided by 5. Well, the opposite of dividing is multiplying. So if I were to take this side and multiply it by 5, which I could do up here, I could take 5 of these marbles or whatever we're weighing over here, and I say, oh, I want 5 times as much, I can put 5 times as much on this side. But if I put 5 times as much on this side, I have to put 5 times as much on that side, and then it'll stay equal. The reason for that is because this multiplying by 5 and dividing by 5 is going to cancel out or equal 1. So 5 divided by 5 is the same as 1, and 1 times x is the same as x. Again, we're trying to isolate our variable. Now, if you have a fraction in front of x, I can multiply by the reciprocal, which means the denominator becomes the numerator and the numerator becomes the denominator. The reason for that is because just like down here where I multiplied by 5, I can multiply by 4. Oops. Get excited. Okay. Okay? But I also need to get rid of this 3. 3 times x. If I want to get rid of the 3, I would divide by 3. So if I'm going to multiply by 4, I divide by 3. And that is a common way to get rid of the fraction in front of the variable. You just multiply by what's called the reciprocal, which is when you take the fraction, turn it upside down, the numerator becomes the denominator becomes the numerator, multiply them because 4 divided by 4 is 1. And 3 divided by 3 is 1, and 1 times x is x. Now I can multiply 4 times 12, which is 48 divided by 3, or I can say 12, it's like saying 12 over 1. 12 divided by 3 is 4, and 4 times 4 is 16. I usually like to divide first just because I'm working with lower numbers, but you'll get the same answer. What happens if I have a negative in front of a variable? Well, I can divide it or multiply it by -1. If I do this to one side, I have to do it to the other. A negative divided by a negative is a positive, positive 1. And 3 divided by -1 is -3. Okay, using these examples. All right, hopefully you got this answer. These answers. All right, let's try the next part. Solving linear equations. So basically when you're solving them, once again, you're trying to get the variable on the left-hand side, hopefully, either left or right, but usually we try to get the left, and then all the constants on the other, because we're trying to solve the mystery. What is x? What is y? What is it, right? This is like a super math, geeky way of solving mysteries, right? Not like CSI. Okay. So when you're solving linear equations, first you're going to combine all your terms on each side. So if I got a bunch of x's on the left, get them all together first, or constants, and then all my constants on the right or x's on the right, whatever. Move all the variables from one side to the other side. If you add or subtract, multiply or divide, just like we did. Isolate the variable. You want it to be all by itself. No coefficients, or a coefficient of 1, and solve it. And then write your equation or your solution in brackets. It's these fancy little bracket things. Okay, so the first thing I have to do here is I can't start moving this x or try to get it because there's this 8 in front of it. So I'm going to distribute. All right, I want all my x's on one side and all my constants on the other. So I'm going to, if I subtract my 8x on the right, I have to do it on the left. Okay, so I have -3x is equal to 24. I want to try to get my x by itself, so I divide by -3. It's okay to divide by a negative. So x is equal to -8. That's how you would do that. Similarly, I got to do some distribution over here. All right. Because I can't work with things that are in parentheses. -3x, -3 times 2 is -6. Let's combine my like terms. I've got 13 minus 6, which is 7. Okay. I want to try to get all my x's on one side. So I get 5x minus 23 is equal to 7. I want to get rid of the 23. Again, I'm doing the opposite of whatever's there. So I get 5x is equal to 30, divide by 5. So x is equal to 6. Lots of steps there actually, but everything we've gone over before. What happens if you have fractions? We all love fractions, right? So the main thing we want to do is find the least common denominator in our fractions. Now, the least common denominator means if you just have numbers, is that you look at the multiples. So I look at multiples of 2. 2 times 2 is 4. 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, right? And then let's look at our 5s. 5 times 1, 5 times 2, 5 times 3. And we're looking for the number that's in common of both. And it turns out to be 10, okay? So if I multiply each one of these by 10, each side by 10, I can get rid of the fraction, okay, by using the least common denominator. Now, we just learned that this can be distributed. Okay, so you can distribute the 10 to both sides or to everything on that side. So let's divide by 10 divided by 2 is 5. And 5 times 3 is 15. 10 divided by 5 is 2. 10 divided by 5 is also 2. And 2 times 39 is 78. Now, let's subtract 2x. So I get 13x is equal to negative 78. Divide by 13. So x is equal to negative 6. All right, now you guys try. Hopefully this is what you got. I forgot to put it in the brackets like it asked me to do. Sorry. Okay, and up here it would be negative 8 in brackets. All right. Okay, look forward to seeing you again.